The TLDW, we baked another video card successfully after breaking then fixing its fan and adding a customized PWM controller. So let's cover the diagnosis process, the fan mistake, the do-it-yourself fan controller, everything that pulled this card back from the dead and allowed it to keep on living. To me, $11 is a fair price to pay for learning material if the class is called graphics card repair and the training material is a presumably dead HD 7770. Presumably because the card is currently running in my PC. It all started with an ad on the main ad site that I like to visit. The seller was putting an MSI HD 7770 for sales as spares or for parts. The ad mentioned a fan problem that required a so-called 5 volts mode, and also some VBIOS issues that prevented the card from working. The 5 volt mode actually requires the fan to be disconnected from the board and have it powered up at a 5 volts line from a Molex connector using just the yellow 12 volts line and the ground black wire from the fan. On a Haswell-based test bench, the card did not display an image, and the AMD VBIOS tool did not detect the card. I connected the fan back to the card, and at power up I could notice the fan twitching, like attempting to start then quickly shutting off. My interpretation of this was a failure at powering up the card, so I started to investigate it as such. By the way, if you like fixing things, you might like a few other YouTube channels that specialize in this. Learn Electronics Repair is one of them. See the link in the description below for more. So I pulled out the multimeter and started measuring the resistances on various PCIe power rails, then on the 12 volt 6-pin connector, then between the various coils and ground, basically checking for shorts. I even started measuring the PCIe data lanes in diode mode to check for any problems there. Measurements pointed out no problems. I then labeled out various outputs and input control signals like enable and decided to measure these signals the next time I'd power up the card. At this point, I switched the test bench to use the FM2 Plus motherboard and APU combo. I slotted in the card without the heatsink and fan and powered it up. I touched the chip to check if it gets power, and the chip was warming up. A monitor connected to it and a restart later, and I was staring at the monitor as it was receiving a valid image from the GPU. At this point in time, I waved out the behavior of the Haswell-based test bench as a compatibility issue, especially since in my Haswell-based workstation, the GPU would give out an image. The fan not powering up was still an issue, so the next set of measurements involved tracking the PWM signal at the blue wire to the transistor responsible for providing it, and then further into the graphics card. This probing stopped at the very first stage. The multimeter detected a 25 kHz signal with a 37% duty cycle at the blue wire. There was no need to check the card. The issue was within the fan. The twitching behavior got me thinking, and before doing any work on the fan, I fired up MSI Afterburner and I started to increase the fan duty cycle just to see if it ever kicks in. And kicked on it did, but at a duty cycle at 80% or higher. Suspecting a mechanical issue like a poorly oiled bearing, I decided to open up the fan. To open this kind of motor used in this fan, one must pull on the fan hub along its axis and do so quite strongly and evenly. I pulled strong enough, that's for sure, because I did pull out the hub. But I did not pull out evenly enough because the fan's axis remained in the bearing. I basically broke off the axle. I wished for it to be a mechanical issue, and I made damn sure it would turn into one. The way I fixed this was to use the superglue and baking soda method. In it, you alternate adding superglue and baking soda to the location of your connection. The resulting material is very strong. So I pulled out the axle and superglued it back to the hub in its original position, using the plastic pieces still attached to it as a guide. I then added a bit of extra glue and sprinkled some baking soda. Rinse and repeat, then Dremel out the excess. A drop of oil in the bearing, and then I pushed the fan back. And while the fan would spin just as well as before the entire superglue adventure, when connected to the card it would still refuse to spin unless the required duty cycle went above 80%. This was not a mechanical issue. It was a problem with the fan's internal PWM controller. At this point I decided not to try to open the fan again to trace and repair the defect in the internal controller. Instead, I decided to treat it as a 3-pin fan with no PWM control, and add PWM control by modulating the 12-volt power line going to the fan. A bit of playing around in LT Spice, a bit of soldering, and the external PWM controller was done. I inserted it on the fan cable, between the connector and the actual fan, then hot glued it inside the shroud of the card. Nothing suspicious from the outside, and putting it inside there allowed for some forced cooling of its components. Inside the Z230 workstation, the card powered up, and the fan finally started to spin at a duty cycle much smaller than 80. The BIOS of the card had it running at 30%, and as the temperatures rose during stress testing, the duty cycle was soon to follow, to keep the card cool. At this point the card was working and the fan was properly controlled by the card. And all was good. Well, not quite so. A few days later, the Z230 beeped when trying to power it on, with no picture being displayed on the monitors. On the FM2 Plus powered test bench, the card was detected by the AMD VBIOS utility, but we could not either read the BIOS or flash another one. We got an error code and the GPU would warm up quite fast. So back to a VBIOS issue. The BIOS chip used by the R7770-PMD1GD5 has one particular signal that caught my eye, a low active chip select. The value for this signal can be measured on pin 1 of the chip, which happens to be accessible when the card is placed in the workstation. And the value that the multimeter displayed for it was 3.3 volts. Definitely a logical high value, meaning that the chip is basically disabled. The various diagrams for interfacing the BIOS chip to the GPU have pretty much the same circuit for the chip select signal. The BIOS chip pin is connected to a pull-up resistor, and then via a small value resistor to a signal from the GPU. The pull-up resistor measured fine, so the list of potential culprits remained as follow. The small 33 ohm resistor failed as open circuit. A ruined connection or trace that connects the junction of pin 1 of the BIOS chip and the pull-up resistor to the 33 ohm resistor, or from said 33 ohm resistor and the GPU. Or the chip select signal is never pulled down by the GPU because the GPU itself is dead. Using the multimeter in continuity mode, I found the chip select signal going through a resistor pack with the appropriate 33 ohm value, then to a via that gets it on the other side of the board where the GPU is located. I managed to measure 33 ohms between the pin 1 of the BIOS chip and the via on the other side of the board. So the circuit starting from the BIOS chip and ending up to the via on the other side is fine, which means that either the GPU is dead or the GPU is not properly connected to the PCB. Since I've seen the card working previously, I suspected the GPU no longer making proper contact to the PCB. I am sure that you know where this is going. No, I still don't have a reflow machine, and no, the hot air station won't do. The GPU is just too big, and hitting it up unevenly risks damaging it due to the mechanical stress. So in the oven we go. This time around I did protect the sensitive electrolytic caps and I preheated the oven. And yes, the procedure worked. The card is running in the workstation as I'm typing the script for this video. When I started the repair for this R7770-PMD1GD5, as MSI named it, I didn't think I'd end up baking the card. While I was successful in the past baking a laptop motherboard, even a USB stick, my most recent attempt did not end up well. I've linked the video to it. So this time around I took my time and diagnosed the issue properly, to avoid throwing it in the oven willy-nilly. However, in the end, the limiting factor proved to be the tools available, or better yet, not available, at hand. The proper fix would be to use a reflow station, but for someone doing repairs as a hobby, the price is prohibitive. Currently the card is running in my workstation and I'll get to see for how long my fixes will last.